Hello, everyone. It is Wednesday, September 8th, and it's time for the Knowledge Bolide weekly hangout sponsored by Topher Meteorites. We have a pretty full room today, some nice new names in here, a friend from overseas, and I'm starting to see some hands getting raised. So I'm pretty excited about that. We're not going to waste any time. Let's just jump right into it. We got to take a little bit of a look at the Aubrite from Algeria that's being classified right now. We're really fortunate to have a sneak peek at some of the actual thin sections that are being used or going to be used in the classification process. They're made by our friend and partner overseas, Jose Garcia, and the material is from Juan Aviles at Jurassic Dreams. So while we're looking at these thin sections, we're going to be talking about enstatite and enstatite-rich stuff. And then I know that there's a whole group of meteorites called enstatites. So that's kind of what we're going to discuss today. Mike, if you can tell us what you know a little bit about what enstatite is and why there is a group of meteorites called enstatites.
Yeah, sure. So the enstatite is a form of pyroxene, so it's orthopyroxene, so it means it's orthorhombic in its crystal structure. And enstatite is specifically considered an end member, right? So pyroxenes are a solid solution series. So at one end of the solid solution series, you have enstatite, which is magnesium SiO3, and so MgSiO3. And at the other end of the solid solution, you have ferrosilicate, which is iron, so FeSiO3. So everywhere in between there, magnesium and iron can kind of substitute in different ratios to that crystal structure. So what you're talking about when you're talking about an enstatite is that pure end member all the way at the end. So like things like Aubrites are like 70 to 98% enstatite. You do have the Aubrites, which are chondrites. And then you also have enstatite chondrites, which are broken down into two different subtypes. There's the EHs, which are high metal enstatite chondrites, and there's ELs, which are the low metal enstatite chondrites. And kind of so the two types of enstatite chondrites are the EHs and the ELs, and they both run from the full petrology series of type 3 all the way up to type 7 as far as being metamorphically altered. There are no subtypes within the threes, so that they don't have a subtype petrology within the threes, but they do run 3 to 7 on both the E's and the H's. And kind of the difference between the two of those is actually mostly in the metal grains. The enstatites are actually a very reduced type of meteorite. So when I say it's a reduced environment, it means there's really not a lot of free oxygen in there when they're forming. So typically you would get certain minerals that form by taking what they call lithophiles, things that want to become minerals, like titanium, chromium, things like that. Well, there's so little oxygen there that they actually don't become lithophiles in the case of enstatites type meteorites. They become what's called chalcophiles, which means they bond with sulfur and become sulfites. Likewise, okay. Usually you would take silicone and you would bond it with oxygen and you make silicates, but there's so little oxygen there that there's actually free. Well, not really free. There's silicon inside the enstatite chondrites and achondrites that wasn't able to bond with oxygen, and it ends up stuck inside the metal. So that's kind of the determining factor between the EHs and the ELs is how much free silicon is bound inside of the metal grains. So in EHs, you'll have 3% free silicon in there, and the ELs, I believe it's like 1%. So that's how they differentiate those two groups, besides having slightly different chondral sizes. But yeah, it's really crazy that they're there's some of the most reduced meteorites out there. So you'll get odd minerals that form in there you don't really find in a lot of other meteorites. You get things like monosulfides. So that's one metal ion and one sulfur ion put together. Again, those are those sulfides that you don't usually get when there's free oxygen, because the metal would just oxidize and form a metal oxide instead. It's much easier to do that.
Mike, you keep mentioning that these a lot of this is due to the lack of oxygen. Would it be safe to assume that that maybe the enstatites are a little bit more firm, a little more solid and dense? Because that's not been my experience. Or does that not play into it at all?
No, that doesn't. I don't think necessarily play into it. I would have to pull the densities of all of the different minerals in there to compare them with kind of the bulk compositions with the other meteorites. But it does kind of tell you about where they formed, right? So that they're a meteorite type that formed really close to the center of the solar nebula when everything was getting going. You know, a lot of the science papers put it around 1 astronomical unit or less for their formation. So they're an inner solar system forming type of meteorite, both on the chondrite side and on the achondrite side. And that's where all that heavily reduced, not much oxygen, solar nebula gas constituents were going on.
Because thank you, I appreciate that. Here's where we're going to be looking at the Aubrite today. It is listed under the achondrites, and it does say that it have enstatite pyroxenes in it. And as you said, it is an end member of this group, and it butts up against the end member of this group. Could this be a continual chain?
So they've actually looked at that, and looking at the breakdown of chondritic material to form an achondrite, they actually do not believe that the Aubrites come from the exact same parent body as the chondritic material. It comes from a very similar, obviously, since they're both so high in enstatite content, parent body, but they're not genetically related. So the EHs and ELs we have are not from the same parent body that's thought as the Aubrites. And it's actually thought that looking at the reflective spectra for some of the different asteroids out in the asteroid belt, 16 Sayh is thought to be the main parent body for the Aubrites. And there's a couple potential parent bodies that they're looking at for the enstatite chondrites. One of them is Steins, and the other is Eger. I don't remember the numbers that go in front of those two. I can go pull those up later and throw them in the chat. But they picked out a couple of potential asteroids that they're thinking have the same spectra as the 3 different types of enstatites. There's 4 ungroups too. So those are enstatite achondrites that they looked at, assessed completely, and couldn't fit them into the Aubrites. Wow. And probably the most famous of those are Zexladze, which is a famous find on the side of the road. So that's kind of a
maybe famous to you. I've never heard of it.
Yeah, it's you don't see it too often. It's hard to run across.
Polish, right?
Yes, I believe that one is from Poland. Yes.
Wow. That is some great information. I'm going to let everyone, if anyone has any direct questions or can think of something right now, like to hit Mike up by all means, because that was a lot of information. Luckily, I'll get to watch it a few times before all the editing and highlights. I'll get to learn it. But if anyone has any questions, we can discuss it now or in a few minutes or after we're done recording as well. Well, like I said, we're really fortunate to have. So thank you, Mike. I appreciate that.
Yeah, no problem.
Good job, bud. We're really fortunate to have a partner with us. Trying to get the right slideshow here. Here we go. So we have actual thin section work from Jose Garcia down there on the bottom, and the material comes from Juan Aviles, and they are both in Spain, and they're both crazy, awesome people. So here's some of the thin sections for the new Algerian Aubrite. And I wish I was intelligent enough to tell you what everything is. But in this one right here, I know that the white, I'm going to hit the pause button. The white is enstatite and the gray is cycloenstatite. And it's formed at low temperatures. In some of these, you can really see the huge crystal structures. And completely, that one is completely enstatite. Yeah. So, oh, yeah. That one shows huge crystal. And then tremendous amount of shock. So yeah, if we had Daniel Shake on with us, he could tell us what we're looking at. So I thought that was pretty neat to have a little sneak peek at some of the actual thin sections made of the Aubrite. There we go. What is that? Oh, in case we didn't see or show the actual Aubrite itself. I'm trying to figure out what that black mineral material is in there. You can see the really long, big, huge crystals and how they shear off like that. This is a solid meteorite. It's hard to cut. We'll have to talk to Chris about that, but it's a pretty solid meteorite. You know, I'm not scared to drop it on my desk.
Well, I was going to actually ask Mike a question about that because I know that he cut some of the same material. So when I was cutting it, I cut it pretty thin. I was cutting it at about 2 millimeters. So I was cutting it pretty thin, but every single slice I cut broke in half, except for the end piece that was glued. The last, end piece didn't. So it was very brittle, very hard. I know that the pieces he cut for the Meteorite of the Month Club were thicker than what I cut. I guess my question is, why is that? Why is it so brittle?
I don't know necessarily if it's brittle. I think you're getting it to separate along the crystal boundaries. It is very large crystal structure. So obviously where two crystals meet up, you got a little bit of a weakness. And I got a feeling it's possibly separating there. Yeah, I did cut it thicker because then I had to do a bunch of cross cutting when I was working on it to get it down to Meteorite of the Month sizes. But I mean, I know bigger slices have been wired off and held together. So I think it's maybe some variation in the material too, as far as, some pieces being a little more weather cracked and stuff like that than other pieces.
Well, it actually turned out because the pieces I cut are smaller, more affordable. They're not these huge, giant, expensive pieces. But yeah, I was just sitting there. Everything was running smooth, and maybe it was a weather crack because almost at the same place in the center of the stone, every time I got there, it just fell off.
Man, that sucks, dude.
Yeah, it sounds like you might have run into a deeper weathering crack or a flaw in there. Like Topher said, I'm interested to know what the shock was on that and how much it was shocked. Because obviously it was found in a whole bunch of pieces ranging in a whole bunch of sizes. So it did a lot of breaking up when it came in.
Oh yeah.
Yeah. So I want to, at first, when things were first coming, when I was first seeing pictures of it coming out of Africa, it was being marketed, if you will, as all the black stuff is fusion crust. And of course, you just see a pile of rocks on a scale. You don't really see individuals in close-ups and high def. So when I got my pack, I looked at it and I'm like, there's no fusion crust in any of these. Like, it is definitely some interlaced minerals. And as you saw in some of those close-ups, it literally goes around the crystals and surrounds the crystals. And you can see that in the thin sections as well. They were set off. So, yeah. So thank you, Juan and Jose, for letting us use those. A lot of work went into those thin sections. Roberto Vargas with his hand up. How are you, buddy?
I'm doing well, man. How are you? How's everyone doing tonight?
Living large. Yeah. Can't wait for Tucson, buddy.
I know, me neither, man. Yeah, I can't wait. So, just a couple things. You know, when we're talking about like hard versus like soft, like in terms of like friability and stuff like that. Let me turn this around. So this is the Aubrite, the Algerian Aubrite. I got it pretty thin, maybe like 1.5 millimeters.
Mm-hmm.
I didn't have any breakage issues except on this piece.
And you're using a saw?
Yeah, I was using isometric and isomet saw, Bueller isomet.
Okay.
So like this stuff in my experience is pretty hard. When you compare it to a very common, well-known Aubrite like Norton County. And yeah. I think Dustin Dickens also has an Aubrite, NWA Aubrite that he was recently selling. And that, like Norton, is very friable. You know, if you sneeze on it, it's gonna crumble into pieces.
Yeah.
So I think it varies. From I don't think it's necessarily like it's not a rule for Aubrites to be super friable or super hard, because when you think about it, even Mount Egerton, which is an Australian Aubrite, it's very weird looking. It's like orange. That stuff is hard. It's like this stuff. It's like it's like this Algerian.
That could be a result of the shocking. If they were both highly shocked. For sure.
And I mean, Norton County is fresh. I mean, it's a witness fall. I know Dustin's Aubrite had very visible fusion crust. So maybe I don't know. I don't even want to guess and say that it may be like terrestrialization or something, but that's just like something that I've seen when it comes to like Aubrites. And I wanted to, we were talking about EHs and ELs. So
can I ask you to turn your camera sideways for a second? There we go. Let's try that.
All right. So Itqiy is an EH7 anomalous.
That is a big piece of it too.
It's about 4.22 grams.
Wow.
So it's the only EH7 anomalous meteorite. At one point it was thought to be a witness fall, and then it was recently changed to just like a find, because studies came out, and I guess there's like terrestrialization weathering that is indicative that it wasn't actually a witness fall. But
interesting.
But as a one of one, it's still pretty cool. When I bought it was considered a witness fall, and then they changed it. I was kind of bummed, but you can't be too bummed on a one of one.
Yeah,
like that, you know.
Yeah, and that thin section is incredibly insanely odd.
Yeah. So that's so like I said, so that's an EH7, and like Mike was saying, EH is an enstatite chondrule, and like with our ordinary chondrites, they come in H for high metal and L for low metal. So EH means it's got high metal in it, and then this is an EL7 Baqiangzi. I know I'm mispronouncing that. Baqiangzi. This is there's only two EL7s. This one's from China. I don't have like a windowed one. But it's kind of weathered. You can see like some roll over there, but it's for a low metal, it's kind of heavy. Yeah. And I have two pieces of that.
I bet no one else has it in their collection in this group. Maybe Mike.
Don't bet.
I was gonna say maybe Mike.
So there's that. There's the ELs. We talked about the Aubrites, and then this is unrelated, but a piece I'm super happy about.
Oh, yes.
That new Hassi LBO'd 002. It's an ungrouped palisite. I put a post up about it recently, yesterday, I think. I just got it in the mail yesterday, so just figured I'd show that off.
Wow, that is gorgeous.
That stuff is so beautiful.
Right? Look at the Widmanstein on that.
I know, it's crazy.
Super coarse. You don't find that in like any other palisite that I.
It's like Widmanstein camo.
Yeah, man. It's beautiful. So as soon as I saw this stuff, Mark had it first. As soon as I saw it, I was like, oh, I gotta get myself a piece.
Wow, man. That is gorgeous, dude.
It's not cheap, but it's worth it. And I did what Mike Kelly kind of suggested when it comes to putting pallicites in this. So we kind of think that if you put them in these containers and they're pressed up against this plastic, they may be more likely to rust. Shit, sorry. Okay, so they may be more likely to rust if they're pressed flat against this plastic. So if you see it's kind of not pressed against there, I put the silica desiccant in there, and then there's a magnet on the other side of this foam that's holding it close to the foam but away from the plastic. So
that's ingenious.
Yeah. That was Mike's idea. I can't take credit for that one. But.
That's awesome. Let me just add to that. The reason why we hypothesize that's a safer way to do it is because any moisture that is in there is now in contact with your piece rather than not in contact with the air.
Correct.
That's beautiful, man.
Thank you. Yeah, this is my pride and joy this week. So
yeah.
All right, that's it.
Awesome. Thank you so much, buddy. We appreciate you.
Yeah,
stopping in. And yeah, someone wrote in the YouTube comments, where's Roberto? He has awesome stuff. So if they're paying attention, there's Roberto. And yes, he does have awesome stuff. Let's go ahead and see if Colin is ready for us to check in with him.
Hello. Yes. Yeah. All right.
Hey,
I'm ready
buddy.
here. Yep. Oh, that work?
There we go. There we go.
Yay.
Awesome.
All right. Sweet.
Thank you.
So, yeah, no problem. First, I'll start off with this a chondrite on group that I got from Topher there. It's really not it's really nice looking, especially under light, but it may not flicker too well. Yeah. This so this one looks really, really, really nice. I'm glad to have it. Nice little sparkles, but it's not. I don't know if it's picking it up or not, but hey. So
it's the most one of the most crystalline meteorites and oddest meteorites out there. Yeah.
Yeah. So that would be number one. The second one here is, I got to fix that after. I have this unclassified 27.64 gram
Whoa.
ordinary chondrite, I guess, probably. I think it was found in Algeria in 2019. And it has like some kind of like secondary plus some like fusion crust on the top there, I think.
Dude, that's oriented, man. That's That's beautiful.
It's really, it's really interesting. I saw it a couple times and I said, okay, I got to get it just because it's a really cool shape.
No doubt.
So
an unclassified meteorite just found out in the desert, probably maybe not even with anything else. Maybe that's the only rock in its group.
Yep. So that's
beautiful.
Pretty nice. Yep.
The brown that you see on there, the black, it's when I say fresh versus non-fresh fusion crust, that is fresh, okay? But what the brown is oxidation in the fusion crust that turns it brown like that. You see it on Vinales, you see it on Chelyabinsk. It's very common, and it's not a bad quality in the least at all.
Yep.
Yeah, it's beautiful, buddy. Congrats.
Awesome. Thank you very much. Second of all, I have my first piece of Allende, I think it's called there. Let me try to get it out there. And this is just a small little slice of it, if it's going to focus properly under this light, but it's a pretty chunky.
That's chunky a hunk of it.
Yeah, it's yeah, I saw it. It was actually from one of the local dealer around here for Meteorite. And he sells like gems and stuff too. And I was just like, wow, this is a really chunky one. I think it's, what is it again? It is 2.71 grams.
Wow.
Yeah.
Yeah, they don't cut them that. I bet that's an old slice because they don't cut them that thick anymore.
Oh, probably. But that's, yeah, I wish there was a little bit more light, but unfortunately,
So that's Allende, a CV3 from Mexico, I believe.
Yeah. I think one of the most studied as well, I think, or best studied, they say. So I think I showed this 2 weeks ago, but since we're all talking about the Aubrites and I didn't have very good light, I kind of just wanted to show this one off, and hopefully this is a little bit better. This is 6 grams, basically.
And that's a complete slice.
Yeah.
Oh, that's gorgeous, nice, dude. Very, very nice.
But yeah, definitely pretty interesting looking. I gotta say.
If you know, I said it last week and I say again, if you showed me that, you know, when I was first getting into meteorites and tried to sell me that as a meteorite, I'd be like, nah, I don't think so, buddy. Nice try.
Yep. And that's all. Thank you.
Awesome. Thanks. Definitely appreciate you. Yeah, showing off those items for us. Some really cool items. I see someone in our group that I am super happy to see in here because Norton Azelmat is a fantastic guy with fantastic stones, and I'm actually meeting him right now for the first time. So, how are you, Norton?
Hello, friend. How are you? I am very excited to participate with you today. This is my first participation in Hangout about meteorites. So I'm very, very proud to be with you, all of you guys today. And thank you very much, dear Topher, for your invitation.
It's my pleasure to have you, my friend.
Thank you very much. Really, I didn't prepare many stuff to show today, except one stone, which is under classification. It is an EL Miltrop. I would like to show it to you all. It is under classification, a nice stone. Maybe I have to.
Ooh.
Yeah, here is the texture.
There we
it's
go.
An EL. with remaining secondary fusion crust. Yeah,
Oh yeah,
yeah,
that looks like a real sturdy stone too.
yeah.
Yeah. Fusion crust on it and everything.
Yeah.
So EL and it's under classification.
Yes, it is under classification. It is an EL.
For those that don't know, Noureddin is a very accomplished meteorite dealer, and I'm truly very happy to have him on with us today. How many classifications do you think you have, Noureddin? Are you still counting?
No, really no. But
Yeah.
it is more than 30, 40. I don't know. And more are coming soon. And the most important one is the CH3, one of the rarest meteorites ever, 50 grams, EH3. Yes, not EH3, but as I said, CH3.
Wow, CH3.
Yeah, CH3.
Mm.
So
Mike Kelly's getting his wallet out. That is beautiful.
This is the end cap, yeah, of the stone. Don't know if it is clear to you. This is my first participation, so I don't know if everything is clear. But I will try next time. I will try, even if it is too late here. This is why I didn't attend the meetings, because it's now 2 p.m. here.
And where are you joining us from?
From Morocco.
Yes. See, that's awesome.
Yes. Yeah. Yeah. So I'm glad I'm with you today. That's all about my participation, and I hope next time I will prepare many other meteorites to show you all, guys.
Oh, that would be fantastic. Yeah, when I saw you poking your head in the room, I was like, oh my God, this is good stuff. We got a VIP in the room. Every
thank
week.
you very much. And I hope my English is very clear. I'm not used to speak English fluently, but I try my best.
Well, you did fantastic. And Noureddin, honestly, it's really super nice to finally meet you, and we've exchanged so much over the years, so it's really awesome to meet you and hear your voice. And very good.
Thank you very much. Thank you very much to you all.
Yeah,
thank you.
And
thank you.
And we love to hear you coming back in the future. So awesome.
Yeah, sure.
Good times.
Thank you very much. Good time.
Thank you. Oh man, I don't know how you can top that. Did Mike Kelly put his hand back up? Let's check in with him.
Hey, how's it going, guys? So you said take out so there's all of the Enstatite chondrites. There's all of the achondrites, the Aubrites, and sitting in the middle, which is where I guess I'll start. I mentioned there were those 4 Enstatite achondrites that can't be put in the Aubrite group. That's a small, tiny little bit, but that is one of those 4. That's NWA 4301. So it's an early NWA number.
Wow.
And it's a 1 of 4. Azelmat showed off a nice EL melt. So obviously Haggounia is a well-known, it's now EL melt rock. You know, for a while it was Aubrite, for a while it was EL3, for a while it was EL6. But that's one of those classic meteorites that has that interesting, very terrestrialized texture to it. So
the veining on it, that's Haggounia 001.
Yep, and it's got about a bajillion pairings. So there's NWA 2965. It's the same stuff. So if you're a new collector out there and you're looking for those ones, don't get. You could see I've bought it a couple times. Sometimes intentional, sometimes not. But every once in a while, you do get a nice piece, and it has chondrules in it.
Oh, nice.
So you can see over there in the corner, there's actually two nice chondrules. The one in the top corner is, let's see if I can get it to focus without taking it out, is a very nice chondrule in there.
Yeah.
So those were the EL melts. There are also EH melts. So there's a couple of those, just a couple NWAs. So there's 10237. That's in there. Let's see if I can get it to focus. And you can see they're high in metal.
Yeah.
There's a lot of metal in there in the melt there. It may say 10% or so as far as metal content when you do the lookup of the way they classify them, but some of them are pretty high. And then you got other ones. This is an EH melt, 4799. But if you look in there, it's got nowhere near as much metal as the other one did. So it's kind of varied. You get some of them never got put totally into groups. So this is an E6. There's a total of 8 of those floating around. Sahara 9456, and it never got put into EL or EH. Doesn't fit either, I guess, or never fully got studied to fit it in there. Wow. But you can see a lot of the Enstatites have beautiful metal in there along with the Enstatite. And again, it's really unoxidized metal because there wasn't a lot of oxygen fugacity going on the parent body to allow it to form any oxides in there. So it's all really raw metal and Enstatite.
I'm glad you keep bullet pointing that so I remember it.
Yeah, no problem. This is a cool one just because it's an American piece. This is Happy Canyon, and that's out of the Southwest Meteorite Labs collection. So that's kind of cool. That's a 101. That's one of the ones that splits the petrology. So that's a EL 6/7. But that's the only one of theirs out there. And then in the back, obviously, since I do all the petrology types and trying to work my way through, I had this as EL3, but then they made it EL melt, so I'm missing an EL3 now. But there's EL5, EL6. Roberto already showed this. I will also. He did probably better on the name than I'm going to do, so I ain't even going to try. That's the EL7, one of 2. And then moving on the H's, I have a EH3. No force. EH5. Those are actually very hard to come by. And then EH6 and EH7s. And then over in the chondrites and the Aubrites, I've showed most of this off before, but you got the classics, Norton County, and you were mentioning the fusion crust. Yeah, the fusion on the Aubrites is actually usually more creamy than it is like a black type fusion crust.
Yeah,
a lot of the black you see in there is actually shock. So this piece has that nice kind of creamy looking crust in there along with some shock going through it. So.
Wow, that's probably one of the best examples I've seen.
Yeah, that was a cool piece, and that's actually from one of the larger stones. That's from the McKinney stone, which is actually named separately and got its own accounting for the weight. So that's kind of a cool piece to have. And Roberto had mentioned Mount Egerton, and Chris was talking about cutting, and I think this it's got the brown on it, which from sitting out on the local soil, stained it. But this has a very coarse crystal structure, whereas a lot of the Aubrites, like Roberto was saying, like Norton, kind of have what I consider like a smaller crystal structure. And I think that also probably has a little bit to do with whether they fall apart when you're cutting them or not. This is pretty much just one actual single big crystal of Enstitite. There's nothing else to it. It's just one growth.
From Australia, correct?
Yep.
Yeah.
Yeah, and I cut like was it 50 or 60 grams of it, and that's actually an intentionally cut piece. That's the only stuff that fell off while I was cutting it. I mean, it really didn't. When I was cutting it, it really didn't pop apart, and that was actually all stuff that came off when I was doing snaps to get it down to the specific sizes.
Mm-hmm.
So it's a relatively hard material. Like I said, I think we're separated on grain boundaries, or where weathering has gotten into it on some of the pieces.
Mike, do you have Bishopville?
Bishopville, tiniest little bit, like minuscule.
Is that friable like Norton?
Yeah, looking at it, that's a bunch of little grains from cutting. So yeah, I would say pretty friable, pretty small crystal structure size.
Awesome.
But it is the tiniest little bit.
Well, I totally appreciate Mike taking us through the full classification spectrum of those. The main mass of Norton County is at New Mexico University, and while I was there looking at it, you look around the base of it and it's so friable, pieces have actually fallen off and are just littered around the base of the main mass. And a lot of the samples that have fallen off were bigger than the sample I have at my house. So it was kind of humbling. So we're checking in with Marissa, a VIP. How you doing? I almost called you babe. How you doing?
I'm okay. I'm doing good. I got a recent new meteorite that me and another person, Travis Rouzer, have been waiting on for a while. It's our first classification. And let me see if I can move it back a little bit and get some. There we go.
Oh yeah.
Much better. But it's our first classification. Was generously donated to us, as from the meteorite community, as a chance for us to get a classification in the Met Bowl. And it's been submitted. We're just waiting for an NWA number now, and Daniel did the classification for us, and it came out to be an H5.
H5, and it has some nice crust on it too.
Yeah, we're both co-main mast owners, and he got the larger piece, and that was my choice actually, because his piece was cut on both ends and it didn't seem that appealing to me. I just really liked the shape of this.
Wow, that's gorgeous. Yeah,
pretty cool looking.
I mean, it's a really beautiful.
It is
Beautiful stone.
Now, for those on YouTube who don't understand, this is a momentous occasion for Marissa and Travis. Travis Rouzer, Keystone Collector. How are you, buddy? This is their first official meteorite that's gone through the classification process with scientists. It's gone through the nomenclature committee, and it's going to be published on the Met Bowl. So this is going to be this is their first published official meteorite. And wow, look at that. Look at that shape. And they're both listed in the Met Bowl as main mass holders of this. So they're tied to this rock together. Congratulations. That's awesome.
Yeah, you can really see all that metal.
Oh, yeah. Wow. In H5, right?
Yes,
Yeah,
H5,
yeah. Okay.
shock stage 3, weather grade 2.
Nice. That is awesome. Well, I know that you're not going to put a saw anywhere near that thing. So enjoy that enjoy it tremendously.
Oh yeah,
That's-
and the last thing I had to show was my Enstatites. It is an EH3.
Ooh,
Look at it.
wow! It's got a lot of chondrules in there.
Yep. I had to snatch this up when I saw it. It was completely gorgeous. It's a Sahara stone.
People are crying for that stone.
And if you can tilt it, Rach, so yeah, you can see all the metal and
Yeah. Wow.
yeah, I just had to get that. I forget the Sahara number, but it's an old stone. Oh yeah, you can show the back of that.
Okay.
Yeah. Yeah, this is the wall
Kind of
with
hard to
it.
see.
You can bend my phone up a little bit.
Hold on.
There we go.
Okay, so NWA 97-159. Yeah, from
Yep.
1997.
Yep, that's my biggest and only EH3.
Yeah, and it looks like it's a it looks like it's a complete cut, a complete slice too.
Let me right back in. But yeah, that was all I have to show.
Awesome. Well, we appreciate that, and also look at that countertop. Is that the slice of Aubrite?
I wish.
Yeah, that'd be nice. Oh, thank you so much, Marissa. We definitely appreciate you showing us. And again, huge congratulations to you and Travis Rouzer for being on the Met Bowl. It's exciting. We're really happy for you guys.
Yeah, thank you so much. That's very appreciated. That's a nice notch on our meteorite belts.
Yeah. And Travis, I know when you're watching this, hey buddy, good to see you, man. Let's go to Roberto Vargas with some other cool stuff.
All right, guys.
And we know he's going to turn his camera sideways as soon as we're ready to.
I will. So, yeah, I just wanted to do a couple quick ones because they've been mentioned. So, Mount Egerton. But I wanted to show something cool about this one. Give me a second. It's gonna go dark for a second. Hello? All right. So there's the Mount Egerton. It's an Aubrite that attracts to a magnet. See that? And it attracts pretty well too.
It was actually originally classified as a mesosiderite anomalous.
Yep, it says it on the side here. M2A, mesosiderite anomalous, but it's also got that achondrite put in there. And then Norton mentioned a CH3, so I thought I'd show my little piece of SAU 290. It's got some crust on it. And a recent pickup from our gracious host, Mr. Topher Spinato. I got Errachidia, I got the low metal and the high metal. And lastly, there's that
I'm sorry, I was on mute, dude. I'm sorry.
No.
I was saying thank you so much for showing that off. I'm hoping that Winonaite it gets reclassified as a polymic Winonaite.
Winonaite-pmict, yeah, that'd be cool. So yeah, so there's that, and then my Haggounia 001.
Whoa.
It's got some nice nice chondrules there. And this was the Aubrite I was telling you about It was recently classified. It's got that crust on it.
Oh,
It's
yeah.
NWA 13304, and it's super duper friable.
Yeah, I was going to say it looks a lot less sturdy.
Yeah. Not something I want to take out of there for sure.
Yeah.
So, yep. So that's it.
Awesome. Thank you so much, man. Yeah, I don't know how long I was on mute, but I was talking quite a bit. So we are checking in right now with our good buddy Marco Gaisser in Germany. Normally he does really good he does very good macro photography and other photography of his oriented meteorites and talks about the nice frothy bubbly fusion crust, but he's also quite accomplished astrophotographer. And today he's going to it's rather a long video, excuse me, but Marco's definitely worth it. And it's about a 12-minute video of how he captures an amazing sun image. So Marco, take it away.
Hello everyone. Today I want to show you a very interesting topic of the amateur astronomy. And this is the solar observation, and a special solar observation, because I have here a dedicated solar telescope, and with this telescope it is possible to show and visualize, for example, prominences. This telescope is built up with some very special filters, because all those nice features of the sun, like prominences, filaments, and the chromospheric network, is only visible at one wavelength, and that's the wavelength of the ionized hydrogen, the so-called hydrogen alpha. So this here, in what you can see here, is an H-alpha telescope. The sun is built up with different atmospheric layers. We have, for example, the photosphere. The photosphere is the layer where almost all the light comes from. And over the chromosphere, it's another layer, which is the chromosphere. And it's only the chromosphere which shows up those nice features like, for example, prominences. So, come on, I want to explain this special equipment here, and I hope you have fun with my video, and yeah, let's enjoy our sun.
Great shot.
Yeah, but before we start, caution, attention. Never look with your naked eye through a telescope or binocular which is not covered with a special filter. You will definitely lose your eyelight during milliseconds. Take care, guys. Never do that. Never ever.
Yeah, guys, what you can see here is the Land LS60 solar telescope, and this is a standard refractor telescope. So we have a lens here on the front, and we have here a very special filter, the so-called Egerton filter. And this filter filters only or spreads the light of the sun in all its wavelength, and filters only the H-alpha wavelength, so that we can here observe the chromospheric details of the sun. What you can see here is a so-called pressure tuning knob. So the chamber of the filter is under pressure, and by turning or focusing this knob here, it is possible to get very exact that wavelength of the H-alpha. This, what you can see here, is the focuser of the whole system, and very, very important here, this one in that diagonal, That's the blocking filter. With the blocking filter, we really get only this one wavelength that we're looking for. Here we have the eyepiece, which makes the magnification. And later on, we will put on a camera, a dedicated planetary camera, and we will image our wonderful star. Yeah, the whole telescope here is mounted on a special mount. This mount is also dedicated only for solar observations. Yeah, I'm standing now in front of the telescope. You can see here the camera of the mount for tracking the sun. And then here you can see the lens of the objective of the telescope, and that red thing is the Egerton filter. And Topher, look where this telescope comes from.
Nice.
Arizona.
Very good.
Okay guys, so let's turn the mount on and let's have a look how the telescope's loose to the sun. Yeah, first thing that the mount does is to bring and level the telescope. Now it searches the GPS data, so the coordinates, the actual time, and with that it calculates the angle of the sun, and now you can see now it's loose to that angle.
That was pretty quick.
Next thing is the telescope now is loose to the sun. The camera on the mount centers the sun, and then it begins tracking.
Looks expensive.
I know.
So let's have a look if we can see something here. Yeah, that red thing that you can see, not very in focus, but that's the sun. Yeah guys, and now I mounted the dedicated planetary camera onto the telescope, and let's have a look onto our beautiful central star. Yeah, here we go.
That was a great edit.
You're now having a live view on the chromosphere of our sun. And what you can see here, for example, on the right hand side is a solar spot. Then that structure on all the surface, on the whole surface of the sun, is the chromospheric network. So the sun is a very big plasma ball, and plasma is ionized gas, and of course the sun has a magnetic field, and the magnetic field goes not only on the surface of the sun but also outside of the surface. And if you have such a magnetic loop, then plasma of the sun gets into that loop and forms prominences. And if we go higher with the
exposure time,
if we go higher here,
whoa,
you can see those wonderful prominences. Look at that.
Oh, wow.
Whoa.
There's a lot going on our sun at the moment.
That's crazy.
Look at all those prominences.
Whoa.
And here again, the surface details of the sun. What I'm doing now is I'm capturing a video. With that video, it is possible to filter all the sharp single images, stack them, and then we get a high resolution image of our sun. That's the post-processing, and with that we can generate, as I told, this great and very sharp images. Yeah, the next thing that I want to do is I want to make detailed images of our sun. And for that, I'm using this 2x Barlow lens, which doubles the magnification of the telescope. And so we get closer to the sun and we can see better all those wonderful details on the surface and, of course, all those wonderful prominences. Yeah, now look how close we are on the sun. Here on the edge, we have the active region, so the solar spot, and those white regions around that spot are plugs, active regions. And also the chromospheric network is much better visible. And let's have a look on the prominences. Look at that. Wow. Isn't that fascinating?
It is. I wonder how big those things are.
Yeah,
What we see here is about 8 minutes old, because the light of the sun needs about 8 minutes to reach the Earth. Now we're looking on the north pole of the sun, and those long dark regions that you can see here are filaments. Filaments are nothing else than prominences, but prominences that you can see on the surface of the sun. So on the edge you can see those loops and those flames, I would say, and if they are on the surface they are colder, and colder means darker, and that's the reason why you can see filaments or those prominences on the surface are darker than the chromospheric network of the whole surface. And of course, come on, let's have a look. Do we have also prominences here? Oh yes, we have. Look at that.
They're jumping off.
To give you an idea, the height of that prominences that you can see is about 5 to 8 times the diameter of our Earth.
Oh my gosh.
Absolutely astonishing. And yeah, big structures.
5 to 8 times the diameter.
Yeah guys, I hope you enjoyed that view on our closest star, our wonderful sun, in that very special spectrum. Yeah, it's absolutely astonishing that it is possible for us amateurs to have a view of that normally invisible details of the sun, and that makes that part of the astronomy so special. Of course you need that special equipment here, but yeah, as you can see, it's really fascinating to see all those prominences, and how fast everything changes. So you can make time lapses, for example, during a half an hour or so, and you will see how the prominences move, for example. Yeah, absolutely interesting.
Wow.
Yeah, that wasn't cool.
Look at that.
He keeps calling himself an amateur.
I know.
Which is, I mean, come on.
Look at this. I have never even attempted to look at the sun before. This was all new for me. Oh, that's crazy. You can fit like 8 Earths there.
Yeah, that's the crazy part.
He has some crazy cool equipment and some crazy cool skills.
Yeah.
So these are all his images. Wow.
Yeah, he took all of those images.
Chances move for.
Wow. This one is right there. Let me pause it. Wow. That is crazy. And those are the filaments he was talking about.
Look at that detail.
Oh.
Crazy.
I would absolutely like. I love Marco and I love you for doing this, but you can't tease us of a time lapse and then not give us a time lapse. Wow, that is gorgeous. Hey, Marco, thank you so much. I'm so happy that you're a member of the Knowledge Bolide crew, because that's something that I've never seen before. And I don't, before I got into meteorites, I didn't think I had very many friends capable of doing that. And if anyone wants to complain that it's not meteorite related, the sun has a big draw on meteorites. So, big influence. So thank you so much. Does anyone have something they'd like to show off? Well, I do have one item that I'd like to show. All right, so here's one of my favorite meteorites, and I had to show off because it's a beautiful, super high quality. It doesn't fit in with today's show, but it's beautiful enough to stand on its own. It's Diogenite, NWA 7831, and it is extremely translucent, as you can see. Yeah, so I just thought I'd bring this out and show it as a backdrop. We had a viewer question about Uraku, or is I think how we're saying a Brazilian iron. And Mike, you wanted to handle that for me, please?
Sure, I could talk a little bit about it. I know they were kind of wondering about price and market fluctuation. One of the things that factors into that is how much is available at the time. So if you look at that classification, it was originally found in 92, and there was like 4 masses of them, and they're all multi-kilo masses, but that's not a whole lot of it, and it's tied up.
Iron.
Yes, it's an IAB, so it's a 1 AB main group iron. Okay. So there's like 117 of those, I think now. So not super duper rare as far as irons go. It does. The interesting thing is it's probably a pairing to Campo de Cilio. Chemically, it's basically indistinguishable. From there. One's from Brazil, one's from Argentina. And I know the person who asked the question was kind of wondering about price change over time. So I looked at some old information I had from old collection data that I've kind of run across in the past. And the piece that I saw from that old catalog was like a 45 gram piece, and it was about like $40. So you're looking at about $1 a gram. And I think that was about a decade ago. So not like right after it was found. One of the interesting things is, there's a lot of it out there kind of now when you're saying, okay, well, there's 4 pieces listed. More was found afterward. So it's kind of one of those things where, if the strewn field's not played out, where they're finding it, more materials coming out. The Met Bull doesn't get updated, but there is more available. The exact amount then becomes really hard to judge. So how much do you put the value on it? If it's a simple volume calculation is the hard part.
Yeah.
One of the interesting things is, I do mostly very small micros and a couple gram pieces. So the other thing that I always look at when you're looking at price for the person who asked the question is what size are you going after? Because usually price is not linear, right? The larger the piece you get, usually you can command a better, lower dollar per gram. It doesn't stay linear. So you go with a micro, you're going to pay a lot more per gram than you get if you're going to go with a larger piece. So if you just like scan eBay real quickly, you look at the small pieces, which are like 2 to 3 grams, you factor in the shipping, you're looking at around $4 a gram, which is the high end kind of what I saw for that particular locality. And then you look at the high end of what's available, and there are some like 700 gram pieces out there. And they're only commanding about 60 cents a gram. As that size increases, the price drops off. So that's always an interesting thing to factor in and think about when you're sizing the piece you want to get and what you can afford and what's out there. I know Pat had posted some comments on the Hangout towards the effect that, a lot of times too, sometimes something will classify and there'll be that major rush for it and the price will start high. And then it'll slowly drop down as there's more available on the market than there is demand for it. Or sometimes the market just eats it all up and then you don't see it. And Pat's kind of points, which I'd like to share, was that, sometimes the market will go cold for a certain piece for a long time. And it's because either, an institution is sitting on it all, or the person who put it in for classification, sold a little bit off initially and then decided to just hold the main mass, and keep the value, most of the value locked up in that main mass, which is, if it's something you're saying, like with Marissa getting her first classification, that's a very special thing, to be the main mass holder. So then they sit on it for a long time. And Pat's point was a lot of times you don't see those pieces break free until someone decides they want to cash out on that piece. And they think the time is right to put some back on the market, or, a whole collection passes hands, or, unfortunately a collector passes away and then the collection gets moved. And then you'll see the market, flooded with some of those pieces sometimes, or that'll be the only availability. It's a small amount of material. So Itqiy is interesting because, as far as I know, that's the only other iron besides Campo that they do cryogenic freezing and cracking on.
Yeah.
So you can get cryo crystals of that one. A little more expensive than Campo, but it's a separate meteorite. It's interesting iron for the person who was asking about it. And that's not a process you see many pieces of in that form. And then there's small individuals out on the market for that one. So,
yeah, thank you very much. That was precise and to the point and really good stuff. And pretty much everything crosses over, not just that one. Whether you're talking about Uruk or whatever. The one thing I will say is, one of the conditions you mentioned is when an old collection comes available for whatever reasons. Unfortunately, you may have to look at the quality of them. We don't know how they were stored, how they were maintained, how long after the curator left the collection are they now being offered for sale. So it would be a good question to ask about anything that has not seen the light of day in a while. What condition is it in?
Right. Yeah. Hi guys. Sorry.
Hey, Pat.
Sorry, I was late. I wasn't being antisocial. My brain said it was Tuesday. The holiday messed me up, and I'm retired, so whatever. But yeah, I think all of those comments are spot on. And Topher, one more thing I might add about old collections too is, tragically, they may not be curated well from a bookkeeping standpoint either, and so unfortunately, a lot of times meteorites get separated from their labels, and or you don't get that collection of 6 old labels. And there's one other thing that I learned a while back in a private conversation. Apparently, Odessa and Canyon Diablo are also nearly identical from a chemical standpoint.
Odessa and which one?
And Canyon Diablo. Yeah.
Wow. Could they have disrupted that far up?
Yes.
That's amazing. Wow.
Or they could be just in a very, very similar orbit, and one hits 1 year and another one hits 100 years later, or what have you. But both of those are meteorites of very significant age.
Yeah. Right on.
And those, of course, we know, because they're in the U.S., we know the provenance of them potentially much better as well, and it doesn't detract from those 2 meteorites.
Well, I feel really bad now that we finally have Pat with us. We have to sign off.
I was hoping I made it before the end, but I'll at least here be for the bench racing after the hangout. So
yeah, like right now we're going to say a quick goodbye, and then we're going to shut down so you guys can't see us. That's why you need to join us live, because we're about to discuss everyone's point of views in a non-recorded chat room. How do you feel about the $1 million Taza main mast being cut today? Thanks everyone for joining. I really appreciate everyone's support. Have a great week.
Take care, guys. Guys and gals.
Bye-bye.
Good night.
Bye.
Bye-bye.